Okay. Ali, can you hear me now?
Yes, sir, I can hear you.
Okay. So please be available after class. I will just take your 2 to 3 minutes.
Okay, sir.
Ha. When rest will leave, then we, try to solve this question. Ali, you can try again. Have you seen the my marked which I have marked the assignment? Have you seen, Ali, the checked files?
No, sir.
Okay. Uh, you know the means the work you or the you did with homework. The other most important thing is that when it is checked, na, when teacher checked it, kindly visit and check the your answer sheet, because this is very important, that where you have wrong, na, uh, you will check it from there. Also, you can discuss if things are not clear. So done, everyone? Means at least understood the question and the approach.
Yes.
uh, Jaslin,
1 second.
so see, I'm going to solve this question. So we have delta H, HF is given already, okay, and this is delta H of fusion, and it is asking entropy change in the surrounding when 1 mole of H2O liquid is formed, okay. So we have to find entropy. We have already given delta H, so we have one very small formula, delta H by T, right? Yeah, delta Q by T, everyone.
Yes, sir.
So the question here arises, what should be the temperature? The H is already given. We have to find this. What should be the temperature? Everyone, let me ask one by one. Okay, one has given me the answer. Other, Jesslyn, what do you think? You can give me the answer in chat box. Everybody can give the answer in chat box, no problem. Hmm. Alina, what do you think? What would be the temperature here? Because temperature is not given, right? So the question is something, little kind fishy, that without temperature, how we can find out this delta S? This is given, but this is not given.
So room temperature.
Okay, Sabiha, you can answer in degrees Celsius, no problem. So the answer will be, there is a hint, you can see, fusion. Fusion takes place at, fusion takes place at, anybody can anybody answer in chat box if you like it. uh, Fusion takes place at, fusion of water, fusion of liquid water is takes place at. Sabiha, what do you think? Hmm? You understand fusion thing, right? Fusion word, have you heard this word fusion?
Yes. Yes.
So what does fusion means? Just give me an idea. I'm not asking for definition. Okay. So Ali have submitted the right answer. It takes place at 0 degrees Celsius. Why? The fusion takes place at 0 degree. Everybody know 273 Kelvin. So we will apply this temperature here. Okay, delta H is already given. If it would be like vaporization, so it will not give you exact temperature. You should know that for in the liquid case it should be 100 degrees Celsius. So this is the one of the good question. Without the mentioning the temperature, exact temperature here, it is just mentioned fusion is happening. That is it. Understood?
Yes, sir.
Everybody?
Yes, sir.
Yes.
So try to solve. There are other questions as well, like this. Like chlorine one is given. So at the boiling point and the freezing point is given for chlorine. But for water, it is already expected from you that you know the temperature. So try to solve the homework. We are going to start our session regarding chemical equilibrium. Yeah, so let's proceed with chemical equilibrium. So see, for chemical equilibrium, as we have already understood that rate of formation, rate of forward reaction should be equal to rate of backward reaction. Okay, in that meantime, what we see, for example, this N2 plus 3H2 is reacting to give ammonia. So what we will see that the reaction of N2 plus 3H2 is equal to dissociation of ammonia. Okay, so rate of forward reaction and rate of backward reaction will be equal. It will be in dynamic condition. At the instant when you see that, you will see that neither nitrogen moles are changing, nor hydrogen moles are changing, nor ammonia moles are changing, but internally they are, these nitrogen and hydrogen molecules are colliding with each other, and they are forming ammonia, and ammonia is constantly dissociating itself and forming nitrogen and hydrogen. Got it?
Yes, sir.
So let's see with the graph thing, like so we are making a graph where we have time and we have rate of reaction. Okay, this two girls, Sabiha and Abir, have, I think, connection issue. So they are constantly coming and going. So see what will happen. uh, we have reactant and we have product. Reactant is converting into product, and product is also in the is converting into reactant. So see, uh, can we say that reactant concentration is decreasing with time, right? But after some time it will become constant. Similar way, the product was at zero position initially, there was no product, but after some time it start increasing, and then after some time the rate of formation of product will become equal. Are you getting this? Wait. The rate of reaction should be equal. So the rate of reaction has become equal for backward reaction. So forward reaction, this one is forward reaction. Obviously, it was more in the initial phase, and this is the backward one. Why it was starting from zero? Because the product was zero at the starting of the reaction. As the reaction proceeds, this rate of reaction of the backward, as the reaction proceeds, this product will, this for example, we have ammonia molecule starts dissociating, and after some time, this T equilibrium, we say it as T equilibrium, when it gains some equilibrium means, like for example, after 10 minutes, this forward reaction means this the reactants which are forming to give product, this is the forward one, and the product which is again forming reactant, which is backward one, becomes equal. That is why this is one of the dynamic equilibrium problem, where reactants is constantly becoming product, and product is constantly becoming reactant. So the rate of reaction for them is equal, and that is why we are saying that this is a case of equilibrium. The ROR of forward reaction, becomes equal to ROR of backward reaction. See, this has already become equal. Have you got this? Ali? Hello, Alina?
Yes, sir.
Understood?
Yes, sir.
Yes, sir. At this moment, when rate of reaction of forward and backward become equal, that is called at that time it has becomes T equilibrium, means at that time. There is another graph where so देखिए, we are making graph with concentration versus time. So what do you think? The concentration of ammonia will increase with time or decrease with time?
Increase.
Increase with time. Uh, Sabiha, what do you think? Concentration of ammonia will increase with time or decrease with time?
Increase with time, sir.
Increase with time, yes. So initially it was at zero because there was no ammonia present. We have already we have only nitrogen and hydrogen. So it will increase with time, and after some time the the concentration of ammonia will not change. Okay. Similarly, what will happen with the concentration of nitrogen? It will decrease with time, right? concentration of nitrogen will decrease with time because it is on reactant side. So obviously it will decrease with time. And the concentration of hydrogen, it will also decrease with time, right? Everyone,
Yes, sir.
Yes, sir.
it will also decrease with time. And there will be a time, that is T equilibrium, where the concentration will be not changing with time. It has become constant. Okay, so why it has become constant? Because of equilibrium. Because of equilibrium. And the equilibrium constant, we have already told that constantly nitrogen and hydrogen are reacting to give ammonia, and constantly ammonia is dissociating itself to form nitrogen and hydrogen. That is why we will see no change in the concentration of nitrogen, hydrogen, or ammonia with time. Have everybody understood this?
Yes, sir.
Yes, sir.
Ah. So
Yes,
kindly
sir.
note this down. Done.
Yes, sir.
1 minute, sir.
Okay.
Done, sir.
Hmm. So I'm making some graphs. You have to the graphs are rate of reaction with time. So this is forward reaction, this is backward reaction. Uh, Another graph. This is obviously backward reaction. Initially, the concentration of product is zero. That is why backward reaction starts from zero. Forward reaction. kindly note it down also and try to comment on it, that which graphs are shown correctly and which are not correctly shown for equilibrium case. For equilibrium case, so this is forward reaction, this is backward reaction. So three graphs you have. Okay, are you getting the question? We have
Yes.
three graphs: reaction, rate of reaction versus time, forward reaction and backward reaction are represented in three graphs. You have to comment on it, that which graphs are shown correctly and which are not. This is the graph versus concentration versus time. So what do you think? Anyone? You can comment on chat, no problem. Okay, got one answer. Please answer. Everybody, try to give answer. I'm not going to, uh, judge you that, oh my god, how this one is so easy, because this is we are introducing the topic, so I'm not expecting you to be perfect on it. No problem. This is reactant. Obviously, its concentration will start from, means non-zero, from above, and it will reduce after some time. Okay, and this product will always start from zero only. I need more answers. Everybody try to come up with some answers. No problem. First comment on rate of reaction with time. Everybody have to answer. Okay. Ali, you have also, you should also answer. No window is open for second graph also. I mean second case also. Concentration versus time. Please answer. I'm seeing some people are not answering. Means what happened? Multiple answers can be also corrected. A single choice can also be corrected. Means anything. चलिए हो गया. Time's up. Now let's see. The rate of reaction with time. Please have everybody drawn the graph. Hello.
Yes, sir.
So please look on the screen, because don't write. No. See the rate of reaction versus time. So the rate of reaction versus time should be equal for forward and backward. The rate of formation should be equal to rate of forward reaction should be equal to rate of backward reaction, right? So in these three graphs, we have only this one where rate of forward reaction, rate of backward reaction becomes equal after some time, right? In this one, rate of forward reaction has been decreased and rate of backward reaction has been increased, means they are not equal, right? So this is not at equilibrium. There will be a point at a single point where they are at equilibrium, where rate of forward reaction, rate of backward reaction are equal. Okay. And here they are never equal, means they are not equal. There is no point in history where forward and backward reactions are same. So only this option is correct, right?
Yes, sir.
And this option only correct at this point. So overall this option is wrong and this option is also wrong. Have everybody got this?
Yes, sir.
Okay. Now look into this concentration versus time. Okay. So concentration versus time, you can see that concentration, as you can see in this graph, that they should not change after having equilibrium condition. So concentration should be constant at equilibrium. So concentration should be constant at equilibrium. So after first we will check in first graph. After gaining equilibrium, okay, what we are seeing that reactants concentration and products concentration both are not changing with time, right? So they are not changing with time. Reactants is also has become constant, like 5 molar, and product is like 2 molar. So they have become constant. Now we cannot observe that the reactants are forming in product and product are forming in reactants, because it has become constant. So this is the case of equilibrium. So this option is correct. Now let's look into second option. In this option also, after gaining equilibrium, the reactants concentration and product concentration has become same. Means sorry, constant. They have become same. That is not issue here, but the concentration have become constant. So that is why this option is also correct. And similarly, this option is also correct because the product's concentration and the reactant's concentration have become constant after gaining equilibrium. Are you getting this? So this option is also correct. Everyone, have you understood?
Yes, sir.
Shall I repeat any graph from the first case or third case?
No, sir.
Sir, the third graph, can you explain for concentration versus time?
Acha, for the concentration versus rate of reaction one. Sorry, concentration versus time, third graph. See, at this position, at this time, what we see that the reactants concentration has become, sorry, this is the product one. After this time, the product concentration has become constant, and the reactants concentration also become constant, and that is the condition for equilibrium, where the concentration should become constant. So reactants is concentration is also becoming constant, product concentration is also constant. That is why equilibrium is established. Understood?
Yes, sir.
हाँ. Noted? Done?
Yes, sir.
हाँ. ठीक. Now we should write some characteristics of chemical equilibrium. Please, copy it down. Don't wait for me. Then we will discuss the characteristics of chemical equilibrium. Characteristics. Characteristics. Done. ठीक है. Okay. We have understood this term, dynamic in nature, right? See this one. You can see on the screen the dynamic equilibrium where the things are going on, but we cannot see the water level was not changing. What we observe that water level is not changing. However, the constantly the drops are coming into the beaker and also moving out. So things are happening, but we cannot observe from our, it is not observable from our naked eye. Since rate of forward reaction is equal to so the things which I was saying, it has been written in language that chemical equilibrium is dynamic in nature. It means that reaction do not stop after gaining equilibrium, and the thing which is actually happening is that the concentration of product and reactant is not changing with time. Why? Because rate of forward reaction have become equal to rate of backward reaction. Done copying.
Done, sir.
I will start explaining. Done, everybody? So see, the first point was simple, which we have done already. The second point, the properties of system are constant at equilibrium and remains unchanged after that. So what the thing is that some properties in equilibrium, like density, density of that system where the reactions taking place, when it has gained equilibrium, it will not change. The color will not change, it will be constant. So the properties of the system, when it has attained equilibrium, okay, it will remain unchanged after that. Got my point? Because the concentration of each product and reactant have become constant. So that is why everything will become constant in that system. The properties will be constant for that. Got it?
Yes.
The second thing, the third point, equilibrium can be attained in closed system only. See, it's quite understandable. Like for example, uh, for example, A plus B is in equilibrium with C plus D. So for example, this is an open system, okay, and D is a gas, okay, and the system is open, so D will leave, okay. So how C will react with D? So it is not possible that it will form A plus B again. So equilibrium cannot be attained in open system. It can be only attained in closed system, right? If some compound will escape, how will the reaction occur in the opposite direction, the backward direction? So this is not possible. So equilibrium is only attained in closed system. The fourth point is equilibrium can be achieved from any direction. Like for example, its example can be understood is like we know N2 plus H2 gives 3H gives NH. I'm writing in this single direction, NH3. Okay, so it is also possible that NH3 is in this side, in the reactant side, and it is forming N2 plus H2. So equilibrium can be established from this side also and this side also. Okay, it is independent of that. N2 plus H2 is forming NH3. NH3 will be dissociating from N2 plus H2. So from any direction, equilibrium can be established. Okay, understood?
Yes, sir.
And the catalyst, the last one, the catalyst do not alter the equilibrium point. Means like A is converting to B and B is converting to A. Okay, and if we add catalyst here, if we add catalyst here, so what will happen? Equilibrium will be achieved little earlier. Will be achieved earlier. That is it. What this catalyst do? It is increases. Catalyst increases. Increases both forward and backward reaction. Backward reaction means the catalyst do what? It ease the path of reaction. Means reaction become easy in the presence of catalyst. So catalyst will make the what it will make? It will make the equilibrium reach faster. That is it. Like let me show graph so that it will be, more understandable for you. So this is for a rate of reaction versus time, and this is the product, and this is the reactant. Sorry, this is the reactant, and this is the product. So if we add catalyst now, nothing will happen, but this will be attained little earlier. Okay, means the time which was from here, it will be earlier. It will equilibrium will be achieved. The rate of reaction will be has been increased for forward and backward. That is why earlier equilibrium will be achieved. Okay, the important point which you have to remember is every point, but you don't miss. I have explained you for a better understanding of it, each and every point, especially this fifth point, but that's okay. The role of catalyst you will understand in chemical kinetics in class 12, no problem. So have you understood the language, the theory, everyone?
Yes, sir.
Yes, sir.
Okay, uh, if you have to note something, please note it down so that we can proceed further. Done. Done, everybody.
Done, sir.
Hmm. So we are moving into some next point. Like for example, we have A plus B, which is giving C. Okay. So we should understand that rate of reaction जो depend करेगा is depending directly upon chances of collision. As the collision chances of A and B will increase, the formation of C will also increase. Chances of collision, which is directly proportional to number of moles. As number of moles of A or B increase, obviously, huh, the chances of collision will increase, right?
Yes, sir.
Yeah. So per unit volume, because if we increase the volume also, that is why it is represented in molar concentration, or molarity. Okay. So when we write about this, we write, or rate is written in this form. You should know rate is proportional to concentration of A and wait. Rate is proportional to concentration of A. Also, rate is proportional to concentration of B. That is why we write as rate is proportional to A multiplied by B. Understood? This is for A plus B giving C. Another example, we have 2A है ना, जो B बन रहा है. Okay, so here rate will be proportional to A. You can write it A as A plus A, right? So A like this. So rate will be proportional to A square. This one we have to use later in this chapter. So rate can be written, rate of reaction can be written like this. Okay. So what we are gonna do, we will use in law of mass action. We will use this concept in law of mass action. Law of mass action. What law of mass action says? The rate of chemical reaction the rate of chemical reaction is directly proportional to the product of concentration terms raised to their stoichiometric coefficient. So see, if we have this 2a giving b, we understood it as rate is proportional to a square. What the according to definition, the rate of chemical reaction, the rate of chemical reaction is directly proportional to the product of the concentration terms. We have only one reactant. We will see this example. For example, if we have this, okay, so the be rate will be directly proportional to very rate of reaction will be directly proportional to the product of concentration. So the product of concentration, the the concentration product of concentration raised to their stoichiometric. So we have this A and we have B. Okay, the coefficient are A and B. That is it. So rate can be said as equal to, we have replaced this with a constant K, and it can be written as this. So the concentration of this reactants, इसके product हमने किए हैं, okay, and the coefficient has been risen to the power of the reactant. Okay. Got it?
Yes, sir.
Please note it down and let me know when you are done. Done?
No, sir.
The other law which we are using here, and this we are using, this we will be using in detail. Law of mass action will be studied deeply under chemical kinetics in class 12. Law of chemical equilibrium. Done. Everyone. हुआ नहीं हुआ कुछ तो बोलो.
1 minute, sir.
Okay. Just let me know when you are done.
Sir, done.
Okay.
Done, sir.
See, focus on this law of chemical equilibrium. We will be using this formula in this law of chemical equilibrium. That is why I have taught you a little, introduce you law of mass action. So law of chemical in law of chemical equilibrium, see, first we are having forward reaction. Okay, in forward reaction, what we can say, this, right? This is a forward reaction. Everyone, Haji,
Yes.
Yes, sir.
and this is backward reaction. So the backward reaction, everybody understood that CC plus DD will convert into AA into BB, right? So see, so the forward reaction, rate of forward reaction, what it will be according to this K, as we have studied in this uh, law of mass action, that rate should be equal to K times, which is a constant for forward direction, will be this, right? Everyone,
Yes,
just
sir.
we have to multiply the reactants and having the power of their coefficients. Okay. Similarly, rate of backward reaction, rate of backward reaction, rate of backward reaction will be K of backward, and obviously this. Understood, everybody? Haji,
Yes, sir.
everybody. So
Yes,
see,
sir.
at equilibrium, what the magic happens? Rate of forward reaction becomes equal to rate of backward reaction. So we will equate these two. Okay, and what will be see? A A B B is equal to KB. This is B. C C D D. And just a little calculation, KF upon KB is equal to just cross multiplication, and KF and KB. Wait a minute. Kf and Kb will be equal to Kf upon Kb. Sorry, Kf upon Kb is equal to this. Again, I'm not going to write this. Kf upon Kb will be equaling to this. Sir, is it opposite? No, it's forward upon backward only, and the reactants. Wait, let me check. This will come this side. It is good, right? So the so the original reaction will be, is this AA is converting into AA is reacting with BB to form CC plus DD, which is in equilibrium. So you will see this formula which we have got. K is what here? K is equilibrium constant. Equilibrium constant. Okay. So understood everybody?
Yes, sir.
So this is the formula for K, which is equilibrium constant. Please first note it down. You have to write from law of chemical equation, right? Please note it down. Done.
One second, sir.
Uh,
Done, sir.
so let's comment on K. What K is? So you should know the definition of it. The ratio of Please note it down with me. So what the language is saying that the mathematical it is actually written the mathematical expression of this in language, that we are multiplying the concentration to its coefficient. In the numerator we have product side, in the denominator we have reactant side. So example, you can see it like we have this. Again, the example of N2 plus 3H2 is in equilibrium with 2NH3. So what we are getting, the K value will be, I'm writing it here. K value will be the concentration of the product. So the concentration of product we will be writing it as this, and we will be doing square of it because the coefficient is 2 here, and the denominator we will be having N2, okay, and we will be having H2, okay. H2 will be having power of 3, right? So this is the way of writing this equilibrium constant. Please note it down. If you are done, just let me know. Can everybody? Hello. there are two types of equilibrium constant. Okay? Two types of equilibrium constant. So K is of two types. K equilibrium, I'm denoting it is as Ke. You can just say K also, no problem. So it is of two types, Kc and Kp. Okay. In Kc, what you have to see here is it is in N by V. N is mole, V is volume. So this represents molarity. You may know this. This represents molarity, and here this will be partial pressure. This will be partial pressure. Actually, we have to fill this square bracket thing. So what should be present here? That will depend that the equilibrium constant will be Kc or Kp. Okay. A second. Understood? So what does this represents? This represents active mass. Active mass. What is active mass? The definition of active mass is the actual reactants which are participating in the reaction. The actual reactants which are participating in the reaction, this is represented by square bracket. When the square bracket has molarity term in it, then the value come will be Kc. If the square bracket have pressure in it, then the value come will be Kp. Sorry, this one was Kc, this one was Kp. This one is only for gaseous product, gaseous system. Obviously, the pressure is available for gaseous only. This one is for liquid as well as gas. Okay, the molarity thing will be present for both things. So this one for gas only. So in gas we know PV is equal to nRT. So P is equal to N by V RT. So we know at a constant pressure, at a constant temperature, P will be proportional to R is constant, no problem. T we have at equilibrium, T will be constant. Okay. So these two are constant term. So we are replacing it with proportionality thing. So P is proportional to N by V. Okay. So we have to, we are going to use that terms. The P is the partial pressure here. Here N by V is the molarity. Molarity means concentration. Okay. So when we will do example now, then it will be more clear to you. So let's see with examples. You will note it down later. Question is, write expression for Kp and Kc. And let's see how it is done. It's very easy. Just you have to do it one or two questions for the reaction. And what's the reaction? First one is CaCO3 is converting into CaO plus CO2. So this is in gaseous form, this is in solid form. Okay. So this question is given. We have to find Kc. So Kc we know it is the it is like this, n by v of or concentration of product will be on numerator and the concentration of reactant will be in denominator. So concentration of product we see CO and CO2. For solid, the active mass for solid will always be unity. So we will be only adding this CO2. Okay, and the this is also solid, so it will be unity only. Okay, you have to note this. This is a kind of note that active mass, this is active mass, active mass of solid is always taken as unity. Okay, why active mass of solid is taken as unity always? Because its concentration does not changes with time, that is why. Okay, so the Kc here will be, the Kc will be this only, and there is no coefficient, the coefficient is 1 only, so we will be having only 1. That is it. Let's see for Kp. Kp, as we know, we have said that it is defined for gaseous system only. So Kp will be partial pressure of CO2. Okay, and that is it. And the power of 1, that is it. Okay, so this is Kc, this is Kp. Everybody understood?
Yes, sir.
Let's see with another example so that it will be more clearer to you. N2O4 gaseous is converting into, I will give you time to note down, please focus here. So N2O4 is converting into NO2 gaseous. Okay, so what Kc will be there? Kc will be the concentration of NO2, right, from the product side, and if the coefficient was 2, so the power will be 2, and the denominator we will be having reactant N2O4, its concentration, power will be 1. Okay, so it's already done. Now Kp, we will see for Kp. Kp will be possible here because it is gaseous system, both are gases, no problem, it's well and good. Partial pressure of the product one, NO2, and the coefficient is 2. The coefficient is 2 here, and in the denominator side we have the partial pressure of N2O4, and the coefficient is 1. That is it. Have you understood these two problems, everyone? The
Yes,
solid
sir.
one you have to take as unity, no problem. If you see solid, then it's well and good for you, just leave it. You have to multiply it by 1 only, so leave it. And Kp is only for gaseous system. That is it. Everybody understood?
Yes, sir.
Alina?
Yes, sir.
Jaslin?
Yes, sir.
Now we are looking for the this what we say units. So concentration unit is you remember concentration is mole per unit volume. Concentration, molarity is moles per unit volume, right? Moles per liter. Molarity is mole per liter, right? Mole per unit volume in liter is called molarity.
Yes, sir.
Ha. So we have one concentration present here. There is no power of it. So the unit of this will be mole per liter. Okay. In the similar way, we have mole per liter ka square. Okay. And we have mole per liter here also, the unit. So it will cancel out and the final unit will be mole per liter. Understood everybody?
Yes, sir.
And let's see the this pressure unit is we already know pressure unit is atm and its power is 1 only. Here also the pressure unit is 1. We will having square here and the pressure unit is 1 here. Okay, so it will cancel out and the pressure the unit finally will come atm. Got it everyone? The unit thing, have you understood everyone?
Yes, sir.
uh, let's do some one more question, then you can leave. Let's try this question. I will be having your 5 minutes only, don't worry. You have this question, third question. H2O liquid is converting into H2O gaseous. Okay, so I'm just means Kc will be Kc will be, see we are having H2O for gaseous, right? And with the power of 1, and we will not write H2O for liquid. Okay, but earlier we were writing acha, the liquid one we have not seen it yet. No problem. Why? Because you have to understand this. Note the this active mass of liquid with gas at equilibrium is taken as unity. If there is gas and liquid present simultaneously, then we neglect the liquid one. That is why we are getting this only. Okay, in the denominator we have 1 and its unit will be mole per liter, right? Because we have only one concentration term here. Everyone understood? Let's see Kp here. In Kp only gaseous item will be there, so we will be having partial pressure of H2O. Okay, and it's the partial pressure of H2O is this, and the coefficient is 1 here, so we will be having 1 here. The unit will be only atm, right? Understood everybody?
Yes, sir.
Yes.
uh, let's see another example. Cu, the more example you will do means you will have the understanding of it. Plus 2 Ag. So we have solid here. If solid comes, you should be happy because we should not include in this rate law of equilibrium. So we are having this equation. I will give you time to note, don't worry. So the Kc will be what? Concentration of this and this. This we will neglect solid. So we will be having only this with a power of 1 only. and we will be having concentration of this and this, but this will be neglected this because this is a solid. We will be only having Ag plus with a coefficient of 2, so the power will be 2 only. Got it, everyone?
Yes, sir.
Ha. Now what is the this what do you say, the unit is, for this is mole per liter. For this mole per liter, it's square, right? So finally the unit will be mole per liter power minus 1. Understood, everybody?
Yes, sir.
And we know that Kp is defined for gas. We can't see gas anywhere in the whole equation. So Kp is not defined here. Kp is not defined here. Have everybody understood this?
Yes, sir.
And the last example, which you have one left, one note left also. We have CH3COOH plus H2O, which is giving what? CH3COO minus and H3O plus. This is an aqueous state. This is also in aqueous state. This is in liquid state because it is acting as a solvent. This is an aqueous state. So cases here will be this plus this, plus of this into this, H3O plus CH3COO minus, right? And the we have two options here, CH3COOH with the power of 1 only. But we will neglect this H2O liquid. This is another special case which we will neglect this. So you have to another note here that if reaction is in aqueous medium, means H2O में अगर हो रहा है, then its active mass is taken as 1. Okay, and what will be its Kp, Ali? Kp, can you say? Anyone? Jaslin, Alina? Kp will be? You can guess, no problem. Kp will be? I have got answers in chat. The answer was correct. Just guess if means Jesselyn, Alina, Kp will be not defined because none of the reactants or products is gaseous, is in gaseous state, right?
Yes, sir.
So only Kp is defined when something is in gaseous form. So Kp is not defined here. Done? Means
Yes.
understood?
Yes, sir.
Please note it down. From where you have to note? From here or from here?
So from here.
Okay. Please try to do homework. I will give you some homeworks. This KP KC thing, and revise it. We have, I think, we have 4 questions. After that revision and keeping note in mind, you can do every problem correctly. Done, everybody? Hello.
Second scroll down.
It's means it's the last one, I think.
Yes, sir. Sir, can you zoom? I can't see clearly.
Jesslyn, done?
Yes, sir.
Ali?
Sir, done.
You two people can leave. Ali, please wait for a moment.
Thank you, sir.
Thank you. Assalamu alaikum. Ali? So Ali, I was saying na, you are doing your work. I have seen your homework, but you have not completing it and still uploading it. Why? Without completing the.
Sir, some
Huh?
of them I don't understand.
So you can ask in the class, no problem, or you can ask it after class also, right?
Yes, sir.
Ha. Yeah.
Sir, if I don't understand anything, I will ask.
Sure. Yeah, you can ask. You can just have time from me after class, right?
Yes, sir.
Like you can, if you have problem now, you can discuss right
No,
now
sir. From next class, I will.
from next class. You
Yes,
know,
sir.
there is a good option of sending messages in chat. I can see only the messages in chat, so just message me, okay?
Okay, sir.
And we will discuss, right?
Okay, sir. Yes,
Huh.
sir.
So you have problem in which chapter? Just asking.
Sir, in the current chapter.
Equilibrium.
Yes, sir. Sir, like it is easy, but then some questions I don't understand. Like little questions.
So, but I haven't given you any homework regarding equilibrium. Today I will give.
Okay, sir. So today I will see if how many questions.
Ha, means when you will practice now, in 10 question you may get stuck in 2 question, but still we will discuss, no problem.
Okay, sir.
And so